Imagine opening Instagram right now, swiping down, and seeing nothing. Just a spinning circle. You wait, swipe again, another blank screen. If an app lacked optimization, every single high-resolution image would need to be pulled from scratch. Your phone's antenna would have to work at maximum capacity to constantly grab megabytes of raw data over the network. Within a few hours, the intense physical strain of pulling those massive files would burn through your daily data cap and completely exhaust a full battery charge. Maintaining a fluid, high-speed scroll requires the software to actively mediate between the app's visual demands and the phone's physical hardware limits. Your brain expects immediate visual feedback, but physical reality is slow. Cellular networks drop packets, signal strength fluctuates, and data takes time to move through the air. When you ask to see a picture, a request must physically travel from your phone, jump across cell towers, route to a distant data center, and carry a heavy image file all the way back to your hand. Software engineers are tasked with hiding this geographical delay. They have to bridge the massive gap between the physical limits of the network and human patience. The solution to bypassing this network delay entirely is a structural concept called caching. Think of a restaurant. If you ask a waiter for a sip of water and they run all the way back to the kitchen to fill your glass, then run back again for your next sip, the service feels terribly slow. A smart waiter anticipates the need. They leave a pitcher of water right at your dining table. The water is already there before you even realize you are thirsty. That pitcher is your phone's local memory. Caching takes the images you've recently loaded and stores them directly on your device's solid-state drive. By skipping the journey to the server and reading the image straight from local memory, the application achieves a mathematically true instant load time. To see how this local pitcher of water is built in iOS, we have to look at how Apple handles memory management. In Swift, developers rely on URLCache.shared. Before making a network request, the app consults this code. It asks, do I already have this image? If yes, the logic routes to local storage, actively bypassing the network entirely. This entire decision tree executes in a fraction of a millisecond. It happens entirely invisibly, between the moment your thumb touches the screen and the moment the image slides into view. This efficient iOS code acts as a microscopic bouncer, relentlessly rejecting unnecessary network trips to preserve your phone's processing power. Caching solves the problem of old data, but if a friend posts a brand new photo, it cannot possibly exist in your local cache yet. To handle new content without freezing the app, engineers use asynchronous loading. The app fetches heavy files in the background while keeping the main interface completely responsive. They mask loading time by instantly displaying a tiny, highly compressed blurred placeholder. This small file travels in milliseconds. While your brain processes the blurry shapes, the high-definition file finishes downloading in the background, silently replacing the placeholder. This engineering sleight of hand hacks human perception. By giving your eyes something to process immediately, a slow download feels instantaneous. Compare this carefully orchestrated sequence to a broken feed that stutters and buffers on every swipe. Every millisecond of buffering serves as a stopping cue, a moment of friction where the brain disengages and the user becomes aware of the interface. By removing these pauses, the app maintains a flow state, where the absence of waiting prevents the natural impulse to look away or put the phone down. Caching and asynchronous loading aren't just technical fixes. They are the tools used to eliminate the friction that would otherwise break a user's attention. There is a massive, complex architecture of memory management and background requests operating rapidly just underneath the glass surface of your screen. This reveals the great paradox of excellent software engineering. Its highest level of success is remaining completely unnoticed by the user. Curious tone? We've seen how apps load data instantly, but the next frontier goes further, using these same background systems to predict and preload exactly what you want to see seconds before you even touch the screen. Your simplest, most mundane digital habits are powered by an immense layer of invisible complexity.